Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and today we're going to finalize the video on the motorizing of the Spindexer. To make the pulley for the spindle on the Spindexer, I'm using a piece of material here that was a previous project that was a mistake. This was originally going to be the back plate for my collet chuck. There's a boss on the back side of it here that's actually being held in the jaws right now. I had this all fitted up where it worked fine, where it fit fine on the collet chuck. This boss back here fit in the recess of the collet chuck. Then I realized when I got ready to put it on the spindle on the lathe that this has a boss as well, and it needed a recess on this side. Of course, I couldn't put a recess on this side. It would have done away with the boss on the other side. So I had to go with a piece about twice or almost 3 times as thick as this piece. But anyhow, this has been sitting in the material bin over there for a while, and it had some pretty big countersunk holes in it. That's going to be right where we want to cut this diameter. So yesterday I filled this up with JB weld. I don't know how it's going to machine. It machined good on facing it back off, so we'll see how it does on the groove. The groove for the belt is going to be right around, maybe half, 2/3 of this diameter. But what we want to do first is get this bored out and to the diameter that will fit the spindle on the Spindexer. I've already got a few measurements made, so we're going to bore for a while, and then we'll take another measurement. The spindle for the Spindexer, I'm sure it was meant to be a nominal size of 1.750. It measured 1.747 with my mic, so we're gonna try to match it to there. That's 729 now. So according to that, we've got about 18 more thousandths to go. So I'm gonna let me look at that against the spindle and be sure that looks. I'm going to take about 10 now. Then we'll check again. Alright, that says 137 or 737 now, so about 10 more thousandths. I want to sneak up on it. I want a pretty good fit on this. There's about 8 thousandths. We'll try that. I believe it needs that 2 thousandths. One of these days I'll learn to trust my measuring equipment, I guess. Okay, that's perfect. I don't use that word very often, perfect that is, but that fits good. So what I'm going to do now is put the spider back behind this so I can set this off. The diameter I want to cut on this is just a little smaller than the jaws on the back, so I can't cut it like it is right here. But we're going to set this up with the spider, and I'll be right back. All right, I got the backing plate in there, spider behind it now to serve as a backing plate. Got it clamped down on the boss again. We're going to take this down to about a 3-inch diameter. So we got a right good little bit to cut. Alright, it's going to be stringy on this aluminum, I guess. So I'm going to cut on for a while here. Probably clean out in between each cut instead of getting a rat's nest like this, bird's nest. But I'll bring you back when we get a little closer. Okay, we've got into this outer pattern of holes here, and we're about about to get into the JB weld. So we'll see how this is going to that's going to machine. Okay, we're just starting to get into the JB weld now, and so far, knock on wood, it's holding in there. We're going to see how it goes. We got about 800 thousandths more to go, a little less than an inch. JB weld is still holding fine. I'm very, very thrilled with that. Let's see how close we are to 3 inches. Need 45 more thousandths to go. Not sure I'm going to be able to get there on that. Nope. I will put a little chamfer right here. I may be able to take a parting tool and get in there close enough to clean up that back edge. Alright, now what I think I'm going to do to cut the groove in for the belt on here, I got so much chatter before, and I don't want to interrupt this JB weld no more than I have to. So I think I'm going to take the parting tool and go down the center of this and cut the depth that I want. That'll take out a good majority of what we need to for the track for the belt, and then simply use the forming tool to clean it up. So I'm going to get that measured and set up, and I'll bring you right back. Alright, I've got the center located on the Z-axis, and what I'm going to do, I'm going to back down a little, speed down. I'm just going to touch off now. And I will set the 0 on the X-axis. And I want to go in at 94 thousandths. That's half the diameter of the belt. So far, so good. Now let's put the forming tool back in. Now let me find my little piece of belt and see what that looks like. Go just a little deeper. Using this parting blade to lay out the track is working a whole lot better. Nowhere near as much chatter. Alright, I'm very pleased with that. So let's turn it around now. We've got a good chamfer on there and here. Just can't quite get in there. I think we're ready to go over to the mill now and put a set screw in this boss. I think that turned out very well. I'm pleased with the way the JB weld held in there as well. I've got the spindle pulley in the mill vise now, and I've located the center on the x-axis and also the center of the boss. So now we're going to drill and tap this for a 1024 grub screw. Alright, deburr this. I'll get all the pieces put back together. Then we'll see about measuring and fitting a belt. Alright, I think we're ready to do the reassembly now. I got to thinking about when I cut the belt, the way I had this mount attached to the housing. I didn't have any way whatsoever to adjust the belt tension, so when I cut the belt the length, it was going to have to be exact. I went back to the mill, set back up, relocated these holes, and put some slots in there. So I've got it pushed all the way to the slack side now, and we'll put this back together, and then I'll cut a belt, and I'll be able to tension that belt with these adjustments down here now. But I've got the spindle back in the housing. We'll put the lock ring back on. Alright, we'll remount the motor. The post on this motor had already been cut off. As I said, I'd used this on an earlier project. But that's just about right to put that out with the flush with the end of that. For right now, I'm not going to worry a whole lot about any run out in this shaft or in this pulley. I'm just going to try to tighten it reasonably well from all four sides. Now our spindle pulley. I'll just snug that up. The grub screws that I'm using for these are what's called a dog head. They don't have the cutting surface on it. It'd be all right if they cut into to the motor shaft, but on this I don't want them to. So they're just little dog-headed grub screws. All right, let's see how close we are to being aligned. That looks very close for the alignment now. And of course the handle will go in here to tighten down on the collet. So what we need to do now is cut some belt material. And I'll be frank with you, this is the first time I've ever done this. Hopefully we're going to get it right the first time. Anybody want to help hold this for me? Now here is what was sent to connect these with. Maybe I can get it to focus. So we'll see how that works. It's definitely going to be a tight fit in there. Alright, there's one end in. Alright, that seems to be together. Alright. It's amazing how a tool I had in my hand 2 seconds ago disappears. Okay, folks, I've got my desktop 12-volt power supply sitting over here, and you're seeing this for the absolute first time. Get these wires where they won't touch. Let's see. Alright, I got a little slippage there. I'm going to have to tighten the belt up a little more, looks like. I'll check the RPMs on that a little later, but I think that's close enough. Let me put a collet in there and be sure it's going to pull the weight of the collet and handle as well. Alright, we'll have to tighten the belt up, and I didn't think about it either. There's a lot of WD-40 on these pulleys where I was cutting them. So I need to clean all that off. Then I'm going to paint this bracket here. I'll bring you back to when we get over on the surface grinder and get ready to make a test cut with this. Okay, overnight I took it back apart, gave the mount a paint job, cleaned the belt tracks out real good. I noticed on the belt that it looked like it was trying to scar it a little bit. I realized I had a burr on the edge there. So I just cleaned that up with a file all the way around. And I found, as far as getting it to track, I didn't, or not track, but getting it to pull without slipping. After cleaning the WD-40 off of the pulleys and off the belt, I also found that I had the belt too tight. When I backed off the tension just a little bit, it actually pulls better, excuse me, and seems to work a lot better. So these adjustment slots under the bottom down here are, I think, very beneficial as far as getting it set up and getting it pulling like it should. I've got a piece of 3/8 inch drill rod. Let's see. This is a piece of tool steel. Very hard material. I'm going to put that in a collet on here and get set up on the surface grinder. I've got a fresh dress on the wheel, good sharp shoulder on it. So we're going to see if we can get turn this down to some dimension, but I'll get set up over there and bring you right back. Okay, I'm set up over here at the surface grinder now. I hope it's so you can see what I've got. I've got the Spindexer mounted on the mag chuck. I've got a couple parallels back here just to square it up with the back of the chuck. And I've about touched off, or I have touched off, and I've set the 0 on my dial up here. I'll be advancing down 1/1000ths at the time, just to kind of take it easy and test on this, see how it does. But let's spin up the grinder first. Alright, we'll turn on our Spindexer. And now I'm just going to pass a couple times through there, just to know that I've touched off. Here's 1/1000ths. One thing I'll have to keep in mind, that as I'm using this, each time I turn a thousandths up here, I'm taking 2 thousandths off the diameter. And occasionally I'm just going to park it under the high spot. Just let it spark out. All right, let's try 2 thousandths. That didn't stall the Spindexer at all. There's 2 more thousandths. There's 3 thousandths, which will be 6 thousandths off the diameter. All right, I think you get the idea. I'll swing this around now, show you the piece. And hopefully you can see that. Very precision ground. So, hope you've enjoyed watching this build, this motorizing the Spindexer. I've already got several items in mind that I need to turn with this. So stay tuned to the channel, and we'll see you on the next video.